All right, everyone, welcome. We're going to go ahead and get started with our fourth day of trigonometric graphing. Today is going to be phase shift. I'm just going to throw the formula up here, just to remind you what it is and what to be looking for. But we're basically going to be moving the graph left and right today. And just should be a nice little review of the first 3 days that we've been working on. And we're just going to have just like a new starting point and a new finishing point technically, but it should be pretty straightforward. So here we go. So today's lesson is titled phase shift. Okay. And again, this could be any trig function. So just going back to the one I've been writing on the board quite often, looks something like this. All right, so we've been working all week with amplitude, quote unquote. You know, we've been working with period, which is the B. We've been working with D, which is your vertical shift. And now we are going to work with this one right here. It's called phase shift. And they call it phase shift. I mean, it's really just, you know, translating the graph on the x-axis left and right. But they just call it phase shift to be fancy. So let's go ahead and just jump in. I'll show you how it works. And here we go. So example number one, let's do a sine graph. Why not? So let's do f of x, 2 sine 4. We'll do x minus pi over 8. Okay, we'll start off with that one. So notice that you see parentheses this time. When you see parentheses, you know that you're going to have phase shifts. Now, I've kind of made life a little bit easier on you. In pre-cal, they don't necessarily have the B factored out all the time. So I'm kind of protecting you for now, and that's all right. But in pre-cal, just notice that you know that you're going to have to factor out the B. You know, you got to put it in this format first before you can really know what the phase shift is. But I'm already going to factor it out for you. All right, so let's just go ahead and just do what we've been doing. Our amplitude is 2. Right, our period is going to be 2 pi over b. In this case, it's 4, so we're going to do 2 pi over 4, which is pi over 2. Right, and then we got our phase shift right here. Our interval length. I'm getting warmed up. Our interval length is going to be period over 4, which is the same thing as multiplying by 1/4. So we're going to get pi over 8 right here. I'm a little off the screen right there, so it's fine. So you pi over 8 is our interval length. And we now have a phase shift of, now just kind of pretend like you set this equal to 0 when you solve for x. If I set this equal to 0 and solve for x, I'm going to get x equals pi over 8. So my phase shift is a positive pi over 8. Now, anytime you have a phase shift, this kind of turns into your new starting point. Okay. And stopping point is really just after you've gone 5 times. Okay, you count the first one as your number 1, and if you just count out your interval length, you know, this is what you start and this is what you count by. If you can start at your phase shift, count out your interval length 5 times, you'll have the graph good to go. Some of you might get hung up and be like, well, Mr. Baker, why aren't we stopping at pi over 2 now? Well, the whole graph just got shifted to the right. So my new stopping point is not pi over 2 now. It's actually 1 pi over 8 to the right. And you could do that algebraically if you wanted to know your stopping point. But again, if you just start at your phase shift and count this out 5 times, you're good to go. So here we go. What is this going to look like? Pi over 8 is greater than 0. So I'm just going to start somewhere to the right of 0. It doesn't have to be too far. It doesn't have to be too small, but just kind of start to the right of 0. So I'm going to start at pi over 8, and then I'm going to count these. So start at pi over 8, and I'm going to count by pi over 8. So 2 pi over 8. 3 pi over 8, 4 pi over 8, and 5 pi over 8. If you do this 5 times, you're good to go, because remember the magic number is 5. So this is sine. My amplitude is 2. Most of the time we would already start at 0, right? But now we're actually starting at our pi over 8. So sine starts at 0. It goes, you know, positive amplitude, 0, negative amplitude, back to 0. So this is my sine graph with just the phase shift to the right of pi over 8. Okay, that's what that looks like. Very good. Let's do another one. Okay, we'll call this example number 2. All right, let's do a secant graph this time. Let's do 3 secant put a 2 there. Let's go x plus pi over 4. Okay, let's do that one. All right, so just start off like we've always been doing. My amplitude is quote unquote 3. My period is going to be 2 pi over b, which in this case is going to be 2 pi over 2, which is just pi. And by the time I do my interval length, okay, interval length is period over 4. So period over 4, that's my interval length. And I do have a phase shift this time. So again, if you kind of just like set this equal to 0 and solve for x, looks like my phase shift is a negative pi over 4. All right. So again, this is what I start here. You know, I start here and then I just count by this. And as long as you do that 5 times, you're ready to go. So what is this going to look like? I'm going to start at a negative pi over 4. So again, we know it's less than 0. Just kind of go somewhere to the left of 0, but negative pi over 4. Now, if I'm going to start at this and count by this, negative pi over 4 plus pi over 4 actually lands on 0. So I'm going to put like an imaginary tick mark right there, even though you might not be able to see it. But if I start at negative pi over 4 and add this, I land on 0. If I add it again, I'm going to be at pi over 4. If I add it again, I'm going to be at 2 pi over 4. And if I add it one more time, I'm going to be at 3 pi over 4. Remember, the magic number is 5. I have 5 tick marks there. And that's all you need to graph one period of these functions, okay? So we have all that fun stuff. Secant, looks like we got an amplitude of 3 right here. So 1, 2, 3, good. So secant, remember that one kind of, if it's positive, it'll start up at its amplitude of 3 and it'll curve in. On the next one, you'll have your asymptote, right? The second and the fourth one are always your asymptotes. So this one starts up at 3 because the amplitude is 3 and curves in. This one will start down 3 and have the U, kind of like the frowny face, right? And this one will be up 3 again and it'll curve in. So this would be my secant graph, just with a little phase shift, everything to the left, negative pi over 4. So I've been nice to you on the first 2 examples. I've given you a phase shift and interval length with the same denominator. Well, sometimes you're not always going to have that. So let's do one without a common denominator. All right. So look at this. Example number 4. Or 3, I should say. Example number 3, sorry. Example number 3. Let's do tangent. Let's do negative 2 tangent. Let's do a 2 there. And let's do x plus pi over 5. Yeah, that'll be a fun one. Okay. All right. Continue on like usual. Period, or sorry, amplitude is going to be 2, quote unquote, right? Because it's tangent. Our period is going to be pi over b now. So it's pi over 2. Got it. Right. And then our interval length, again, is period over 4. So by the time I do period over 4, that's like multiplying by 1/4. So it looks like my interval length is pi over 8. And I do have a phase shift this time. So if I set that equal to 0 and solve for x, I'm going to get a negative pi over 5. Now, notice that these do not have the same denominator. Looks like the common denominator is going to be 40. That's okay. All right. So in other words, I'm going to transpose this interval length in my phase shift so they have the same denominator. So if I multiply this by 8, I'm going to have negative 8 pi over 40, right? And if I multiplied this by 5, I'm going to have 5 pi over 40. Okay? So again, get a common denominator if you need to. This is still where you're starting, and this is still where you're counting by. Okay? This is still what you're counting by. All right, so again, looks like I'm starting in the negatives, but that's okay. So if I was doing this one, I'm going to start at, you can kind of do it in your head. I'm going to do it like this so you can kind of see what's going on. I like to keep them evenly spaced out. Why did you put 2 marks on the left, right, Mr. Rager? Well, if I'm going to start at negative 8 pi over 40, and I'm going to add this, I'm still going to land at a negative 3 pi over 40. And if I add it again, I'm going to be at a 2 pi over 40. Add it again, 7 pi over 40. Add it again, 12 pi over 40. So the only difference between the last two and this one right here is that I just got a common denominator with my phase shift interval length. Sometimes you have to do that, and that's okay. So we started here, we counted out 5 times. We're ready to do tangent. Tangent, its periodic behavior would always start at 0. So I'm going to still start at 0. My amplitude is -2, so I'm going to go ahead and go down 2 on this next tick mark, of my phase shift, of my interval length and all that fun stuff. The middle one is the asymptote. So this is your asymptote now, right? And you're back at the opposite, which would be up 2, and you're back at 0. So, it's like 0, negative amp, asymptote, positive amp, 0. So this would be a negative tangent with a phase shift of negative pi over, with a phase shift of negative pi over 5. That's what we're looking at. So we could continue to do this on all day, whatever trig function it is, but really that's the only difference between the first 3 days and today. You just have a new starting point, and then you count out 5 tick marks, and and always land on those tick marks with your periodic behaviors and the dots that we've been working on. Okay. Well, just like the previous 3 lessons, you do have to write the function given the graph. So let's go ahead and practice that, see what that looks like. It's a little different than before. So we'll do 2 of those. Example number 4. What if I, the directions will say for this one, write the function, right? So here's the graph. All right. So while you're copying that down, nope, sorry, I'm a little off the page, but there you go. So write the function given this graph. Now, just like the problems in the previous 3 days, you might, this graph might continue on, and that's okay because obviously, these do go on forever. But when I highlight these specific points, okay, I'm trying to tell you what kind of a function it is, because remember, sine and cosine look very similar. This could be a sine function. It's just translated in a different way, So keep that in mind. When I give you these 5 points, hopefully you can see that it's cosine. So everybody should be able to get partial credit on this kind of stuff. You think, all right, Mr. Baker, I know that this is cosine, right? Because I start up and I finish up. So this is cosine, right? You always divide a graph in half to kind of figure out its midline, to figure out the amplitude, right? So if this looks like there was no vertical shifts on this, but that makes my amplitude a positive 2 because I started up. So I got 2 cosine. Everyone should be able to get phase shift because you can just tell by looking at the graph what it is. So in parentheses, it looks like I started at negative pi over 4. So how do I put that in parentheses? Well, just do the opposite, a positive pi over 4. So there's my phase shift. All right, whatever you start at, just put that in your parentheses and do the opposite of. So that's where I start. Phase shift, pi over 4, got it. And there was no vertical shift, so I don't need to put anything out here as far as D goes. But I do need to figure out the period. Well, the period is a little different this time, because the period is like one full, period of the graph. You start up, so you finish up. That would be one revolution, I guess. So with phase shift, the past 3 days, you would just look at the last point, set that equal to your period formula and solve for B. Well, phase shift is a little different. You always need to do the last one minus the first one to figure out the true period. Okay, so if I did 3 pi over 4 minus the first one, which is negative pi over 4, I'm going to get plus 4 pi over 4, which is just pi. There's my period, okay? But to figure out what B is, this is where you would set this equal to 2 pi over B. So if I did 2 pi over B equal to pi, and, just a shortcut, just like we've done before, if you just switch these you're going to have 2 pi over pi. So it looks like b is 2. There you go. Plug 2 up right there. You have written the function for this graph right there. Pretty straightforward. Okay. Let's do another quick one. We'll call this example number 5, and we'll call it a day. So again, if I gave you this graph, oops, let's do that one. Sorry about that. All right, so let's go with that point right there. Sorry, that doesn't need to be there. All right, but here we go. When you're looking at this, hopefully you can just glance at it and be like, Mr. Baker, that looks like a cotangent graph, but it's not a positive cotangent graph. It's actually a negative one. So let's go ahead and just get partial credit. You know, this is going to be a negative cotangent graph, right? You always divide these graphs in half so you can figure out the vertical shift. You know, so if I cut this graph in half, like right along here, you know, you'll be able to do this on your paper. It looks like my vertical shift was a +1, so I know I have that out there. And from this vertical shift of +1, it looks like you have a amplitude of 3. In other words, you went down. Mr. Baker got way off right here. An amplitude of 3. This is it right here. That's what I'm looking for. Sorry about that. You got an amplitude of 3. Sorry about that, guys. But anyways, amplitude of 3. And because it starts down, let's make it negative. So you get -3 cotangent. Okay. Both of those points are bad. And so we got that part. Now it looks like our phase shift is pi over 2. Like that's where we start. So if I did x minus pi over 2, I now have my phase shift taken care of. And the last part is just a period. Remember, take the last one minus the first one. So if you did the last minus the first, and I just got my common denominator, this is really 2 pi over 2 minus pi over 2, which is going to be pi over 2. Now I can set that equal to pi over b and solve. So it looks like b is 2 again on this one, right? There's your function. Writing the function going backwards. Thank you all for watching. I hope you guys enjoyed this, and I will see you soon.